In Lesson 1, we saw why guardrails matter when you build with AI. In Lesson 2, we learned the PIV loop, plan to implement to validate, as our basic unit of work. Here we will be continuing our exploration into the Agentic AI foundations. Now we're zooming out to see the entire system you're building in this series. The front-end layer, the back-end layer, the database layer, and the infrastructure layer. These layers are not just abstract ideas. They're implemented in your full-stack foundations repo, the template we will use to build agentic AI applications. By the end of this lesson, you'll be able to trace a feature from the user's click down to the database and back, see where each of the 5 guardrails lives in the stack, and understand where your PIV loops plug into this model at this left-hand flow, from click to database and back. It's the life story of a feature in 6 steps. 1. The user clicks a button in the UI. 2. The front end sends a request, like post/API/tutos. 3. The backend validates input and runs business logic. 4. The database stores or retrieves the data. 5. The backend sends a JSON response. 6. The front end updates the UI so the user sees the result. Every real app you build with AI follows this pattern, no matter if you're using React, Vue, Fast API, Node, Rails, or anything else. In this series, your Foundations repo encodes this flow. The front end is a React plus TypeScript app. The back end is Python and a Fast API service. The database is structured and versioned, for example, Postgres. And infrastructure ties everything together so you can run it locally and in production. The PIV loops you'll run later will always be operating somewhere inside this 1 to 6 journey. Let's start with the front-end layer. This is where the user actually lives. In our Foundations repo, that's a React plus TypeScript application, structured so features live in their own slices instead of one giant app.tsx. The front end is responsible for rendering screens and components, managing local and view state, forms, filters, which tab is active, calling the backend API, showing loading, success, and error states. Under the hood, we attach guardrails here. TypeScript in strict mode to catch tight mismatches. ESLint and formatting to keep code consistent. Component tests for critical components. Optionally, some end-to-end tests that exercise the UI plus backend. When you run a front-end PIV loop, plan might sound like front-end lane, render a workspace list using mock data, and show an error message if the API fails. You implement that with AI, but in validate, you rely on TypeScript checks, front-end tests, linting, and an actual click in the UI. So even on the front end, the PIV loop is backed by the same 5 guardrails. Next, the backend layer, API endpoints and business logic. In your repo, this is a fast API service, usually structured something like core/ for app setup and infrastructure, shared/ for cross-cutting helpers, features/ for vertical slices like workspaces, tasks, and so on. The backend is responsible for routing, defining endpoints like get/API workspaces, validation and security, checking data, auth, permissions, business rules, the actual meaning behind those endpoints. Backend guardrails include PyTest tests for routes and logic, Pydantic models or equivalents for schema validation, rough or other linters for style and bug catching, structured logging for observability. Backend PIV loops might be add a get/workspaces endpoint using the existing workspace model and patterns, and write tests for success and failure cases. The AI helps implement, but validate means PyTest passes, linting is clean, types are correct, logs look sane when you hit the endpoint. Under the backend is the database layer, which in this stack is PostgreSQL. Its job: persist data reliably, maintain tables, relationships, constraints, protect you from bad data even when code is imperfect. In your repo, that shows up as ORM models, for example, SQL Alchemy models. Migrations to evolve the schema over time. Maybe some seed data for development. Sometimes you'll run a DB-focused PIV. That plan. Add a status field to tasks with allowed values: to do, in progress, done. Implement. Ask the AI to update the model and generate a migration. Validate. Run migrations in dev test, run backend tests, and maybe add one more test that asserts the new field works as expected. Here, the guardrails are: migrations running cleanly, tests staying green, constraints behaving as designed. Finally, we got the infrastructure layer, how everything runs and how we watch it. In your Foundations repo, that includes things like Docker and Docker Compose files to run backend, front-end, and database in containers. Environment variables and config for different environments. Logging and health checks for monitoring. Infra PIV loops are less frequent but really important. Add a local mail service to Docker Compose. Oh, introduce a health check endpoint. Oh, improve logging formats so errors are easier to parse. The guardrails here are: containers starting correctly, health checks passing, logs being clear and structured. Here's a visual manifestation of the guardrails by layer. You can see some examples of what you might find at each layer in the architecture. On the front end, tests, component plus E2E, lint and style, types, lint. On the back end, tests, lint and style, types and validation, logging. On the database, migrations, constraints and keys. On infrastructure, config, logs, health checks. All of that rolls up into the 5 pillars we've been talking about: tests, linting and style, type checks, logging, and architecture. Architecture shows up in the way we separate layers, use vertical slices, and keep features cohesive instead of scattered. When you run PIV loops, you're always asking, which guardrails should we hit in the validate step for the layer we're working in? Here's the part that future-proofs these lessons. Today, your Foundations repo uses React plus TypeScript on the front end, Fast API and Python on the back end, Postgres as the database, Docker for infrastructure. But tomorrow, you might be working in Next.js, Vue, Svelte, or something else on the front end. Node, Rails, Django, Go, or another backend, a different database or cloud provider. The names can change, the shape doesn't. User to front-end to back-end to database to back-end to front-end to user. Infra underneath, guardrails at each layer, PIV loops as your unit of work. When you learn this shape, you can drop into almost any codebase and make sense of it fast. And you can design stacks where AI and agents can contribute safely. Let's recap Lesson 3. A modern full-stack app has 4 main layers: front-end, back-end, database, infrastructure. Every feature flows from click to database and back. Each layer has its own guardrails that map to our 5 pillars. Your Foundations repo encodes this whole model, so it's reusable across projects. PIV loops operate within and across these layers to build full-stack features safely. You might take a moment and stop the video and study this model very closely. It combines all of the features of the graphical models we have seen in this video. So take note, as this will be used over and over again in some form or the other to create rock-solid agentic AI applications that can be used for all types of operations and workflows, business or personal. Here's some homework. Take any app you've built or are building. Try to map it to these 4 layers. What's your front end? What's your back end? What's your database? What infra do you have, if any? For each layer that exists, ask, which of the 5 guardrails are present? Which ones are missing? In the next module, we'll actually build and extend those foundations, running real piv loops inside this stack. Thanks for watching Lesson 3, and please subscribe to the channel and hit that like button. This helps this series become available to more people interested in developing agentic AI applications that really work. See you in Lesson 4.